nurturing the future of the student community. He pursued his Bachelor of Engineering and Master of Engineering degree in Computer Science and Engineering at National Institute of Technology, Tiruchirappalli. Master of Business Administration, Information Technology, and degree and Doctor of Philosophy in Management Information System, Business Analytics at the University of Massachusetts Lowell, US. He pursued his Bachelor. Mr. Xavier Babu has demonstrated his versatility and leadership through a series of distinguished roles, including Senior Software Engineer at Wipro Technologies, Manager of Software Development, and Principal Software Developer at SAS, Greater Boston for almost 11 years. Currently, a Senior Director at Publicis Epsilon, Boston, Massachusetts, United States, and adjunct faculty at Northeastern and UMass Lowell University of Massachusetts Lowell, Publicis, US. Indeed, his leadership quality and extensive experience across various capacities serve as a testimony to his talent and capacity. We are grateful for accepting our invitation to deliver a lecture on the topic text mining. Text mining draws from the various disciplines, including computer science, multiple fields. Develop a holistic understanding of the data analysis and gain a comprehensive understanding of text mining and its applications in various domains. We are truly honored to welcome Mr. Xavier Babu among us, as his wealth of expertise in the field of text mining promises to enrich our understanding and broaden our horizon. I extend a warm welcome, Reverend Sister Dr. C. Sibana, our Secretary, and Reverend Sister Dr. J.C. Fernando, Principal of our college, for their constant support for the excellence in all our endeavors. I welcome our HOD, Sister Rita, a good planner and executor, and our faculty members, my dear students. I wish you all have a fruitful session. Once again, I welcome you all.
Sir, are you audible to you, sir?
Yes.
Thank you, ma'am, for your warm and wonderful words of welcome. Knowledge alone is not powerful. The sharing of our knowledge is when knowledge becomes more powerful. Now I request the Honorable Resource Person, Xavier Babu, Senior Director at Public Epsilon and Adjunct Faculty at Northeast and UMAAS Lowell, US, to take over the session. Over to you, sir.
Thank you. Thanks a lot. And good morning, everyone.
Good morning.
It's really a great honor to do a presentation or a tech talk among all of you. And you can stop me anytime when I do this presentation, when I do this talk. You can ask questions either through chat or even you can ask either in English or Tamil, doesn't matter. So you can ask me a question. At the end of the session also you can ask questions. Okay. Let me share my screen. Oh, can you allow me to share a screen, please?
Sir,
if you can make me as a co-host or something, I can share the screen.
2 minutes, sir. I will get back to you, sir. We have a technical glitch here. I'll get back to you, sir.
No problem. Take your time. In the meantime, let me give some intro. I know you all are from Sister Rita. I came to know the professor. I came to know you all from the first year to last year, final year, or the even graduate students. It's all mixed up. So I'm trying to cover not too deep as well as not too low, so that you all can understand, what is text mining in a basic level, as well as I will give some examples more advanced level in case you are interested or if you want to do any project or research in the upcoming years or even this year, you can do those projects, as well as you can reach out to me via email or WhatsApp. I can also guide you along with your professors if needed. Okay, let me share my screen. So today we are going to talk about introduction to text mining because text mining itself is a big subject. Even I can take a text mining the subject for the entire semester. Okay. So here I'm just giving an introduction and the basics, the foundation, so that from here you all can start.
I left a meeting.
Yeah, and learn more and start and learn more about text mining. So what is text mining? It's a process of discovering a different hidden patterns. For example, you guys know in Amazon there is a product review, right? Or in the hotel in Booking.com, you have the hotel reviews, right? When someone reads the review, we know from the review,
Excuse
is it
me,
a
sir.
positive review? Yeah.
Sir, excuse me. Sir, actually, it's being projected on a large screen. So there is a technical problem they are connecting. I have joined in my mobile. So can you please just wait for 2 minutes, sir? I'll tell you
Sure.
when it's ready.
No problem.
Do you understand me, sir? Are you getting me? There's a technical network issue. So it's being projected in a large screen and all the students are watching. So there's a problem in the system with the network. So they are trying. So please wait for 2 minutes. Sorry for the troubles.
No worries. No worries.
Thank
Take your time.
Thank you, sir. Okay, sir. I will leave, then you get it. Sound.
Sir, are we audible to you, sir?
Yes.
Five of the screen sharing, sir. I've given you four options. You can try to share screen.
Sir, it's audible. Can share your
Yes.
screen, sir.
Okay. Yeah, I can share now.
Yes,
Can I start now?
yes, sir.
Okay. All right. Thank you. So text mining is the process of discovering some hidden patterns from any unstructured data. So what is unstructured data? Before I go there, what is hidden pattern? When you read the reviews, like product reviews in Amazon or in Booking.com or any other hotel reviews, when someone says, and the food is very tasty, it's a positive review, or if they complain, the rooms are not clean or the service is very poor, that is a bad review or negative review. Like that, there are some hidden patterns in the text, right? It will tell you that a sentence is the positive review or negative review, or what does it mean, or it's talking about a particular topic. For example, a sentence may talk about science or some fiction or some history, right? Or even some other languages, different topics, right? So how to identify those kind of hidden patterns and then retrieve the information? That is text mining, right? And when we say unstructured data, you all know by now, hopefully, the relational database like Oracle, MySQL, SQL Server, where you have tables and columns, constraints, foreign keys. It's all well structured. Or even if it's a JSON data, in some cases, is well formatted with the objects and everything, right? But so here, it's that the text can be in any format. It can be just a Word doc or CSV file or normal text file. It can be anything. There is no structure, right? So text mining is the process of discovering any hidden pattern, what we are looking for, right, from unstructured text data. So that is text mining. So what we do in text mining, right? So text mining tasks include text representation. We can talk about more in the coming slides probably. The information feature extraction. What is information feature extraction? You may say, from this sentence, I can retrieve information about Python language or some AA model. It talks about some AA model. It talks about a particular history, right? Or it talks about some chemical reactions, right? So we are retrieving some information, right? That is, or any feature. Feature means in this case, it can be even an attributes or set of attributes, right? We extract those values, right? Those information. Or text clustering. So we can say if there are 10 different sentences or millions of sentences, some talk about science, some talk about math, some talk about pure grammar, some talk about only within science, only biology, some talk about only chemistry, like that. So there are different topics, right? How do you cluster those millions of sentences? This 1,000 sentences belong to chemistry. This 1,000 sentences talks about physics. This 100,000 sentences talks about some fiction, right? How do you cluster? Like clustering means grouping it, right? So you can group the sentences, whatever you have, right? That is called clustering. Or text classification. As I mentioned before, whether it's a positive review or negative review, or it's a neutral, or a particular sentence about a medical report that talks about that person has a disease, or person is not having any disease, like a benign, like no impact, no issues. So how do you classify from the sentence, from a text? So there's classification and so on, right? So another topic is the interesting topic is information retrieval, right? So that is similar to your Google search engine, right? So it deals with the problem of finding a relevant text document with respect to the user inputs. Maybe you do something in the Google, what is AI or what is machine learning model, what is text mining, right? You type something, right? So based on your input, but does not explicitly address the problem of discovering patterns. So the information retrieval is closely related to text mining, but not exactly, right? Particularly the data processing stage. Yes, it's similar, but information retrieval is not equivalent to text mining. Sometimes people think, oh, search engine is text mining. Not exactly. Okay. So now let's talk about different terminologies of text mining. Maybe the first half an hour, let me talk about this concepts and some basic foundation. Then I may show some Python code, how it works, how can we do different sentiment analysis, or how can we do a different representation of text analytics, the text. I can show you that the second half of the session. Okay. So the terminology, the first one is a document. I think you guys know document like a Word document and all those things before. It's similar. A document is a sequence of words or any other textual data, right? The examples, maybe sentences or paragraphs or chapters or mini pages or web pages or email, the body of the email, right? All those things are documents. The counterpart is a structured data is a record in a structured data set. Maybe in an Oracle database table, the one record may have many columns. That may be a one document, right? This is a counterpart, right? So because whenever I say many columns, each column is an attribute. So we call attribute, right? So all those columns with the data in one record is the counterpart of a document, just for mapping. The next terminology is called term. The term is usually a word, but it can also be a phrase or several words. For example, if this is a sentence, your term is usually a word, but this is one sentence, right? Up to word. So here, several is one word, phrase is another word, also is another word, or word itself is another word, right? Like that, each one is a word, right? And each one is a term, okay? Or if you say the food is good, the good is a word, is a term, or the food is not good, the not good, the two words can be a term, right? That's why it's saying that it can also be a phrase or several words, because the good meaning is different than not good, right? So you have to use two words in a term so that the AI can understand that food is not good or bad, right? The counterpart of a term in a structured data is an attribute or a column in a table, right? The third one is called a corpus. Corpus, you might have heard this, maybe master's students or the final year students of bachelor's degree, when you do EI with the BERT models or how the pre-trained models, they say be like a Hugging Face model. They always say we pre-train our models using a corpus. Corpus means collection of many documents, like millions of documents, right? So the counterpart of corpus is a structured data set, maybe the entire table or many tables, right? The last one is a dictionary or a vocabulary or a lexicon. It's a corpus. It's similar to corpus, right? It's a corpus, but set of only unique terms in the corpus. Well, what does it mean? If you have many sentences or millions of documents, it only takes the unique words. For example, if the word science is there for 100 times, it will take only one, right? The unique word. That's why it's called dictionary. Dictionary means you will have that word only once, right? You all know that. So that is dictionary. So now let's talk about the text representation. How do you, okay, now we are talking about text mining and we want to find the hidden patterns from text, blah, blah, blah. But how can you do it? How the computer can understand that? When we read a text or a sentence, we can understand, right? We understand the meaning, then we know what it is talking about. But how the machine learning can understand this? How can we tell the machine learning such a way so that it can understand, right? So we have to convert the sentence or sentences in a different format so that the machine learning can understand what we are giving, the input, right? So that is called the text representation. For example, bag of words representation. So what does it mean? A text document is represented by a collection of words. Ignoring the grammar, there is no grammar. Whether you wrote it in grammar or no grammar doesn't matter, right? The sentence, it won't consider grammar. It won't even consider the word order. For example, the sentence has a text document, it won't follow the order, okay? And it won't follow the sentence structure, okay? And it will remove all the punctuations and commas and all those stuff, right? For example, let me show an example. So you can see my screen, right? This is our Jupyter notebook. So here what I'm saying, there are three sentences. And the first sentence is called, this is a sample document. Second sentence, we will use this document for text mining example, blah, blah, right? So for these three sentences, when you run the bag of words conversion, the representation, it will convert all these three sentences, these three sentences into a single array. Just array, and then only the word. Okay, it removes this, is, those kind of stuff. It removes will, all those stuff. It removes any full stop like a punctuation or period or full stop, whatever you name it. Or if there's a comma or apostrophe, it removes everything. It just uses only the meaningful word. Okay, it removed we, will, all those stuff, right? So even it removed from, it removed from. So all those grammatical things got removed. So it only collected the word, and there is no order, right? It can be any order. So this is called bag of words. Okay. Then what it does after this, it generates a matrix. Okay, for the same bag of words. Okay, so the data may be column 1, document may be column 2, column 3, column 4, so on, right? For the data, so under each row here, each row is sentence 1, sentence 2, sentence 3. Okay. So what we are saying here, the document, the second word, the data is not, but the document is there in sentence 1, right? But the data is not there in sentence 1. So that's why the data is 0, but the document is 1. Similarly, if you come here, probably the text, the word text, probably there 2 times in the last sentence, here and here. So that's why it says the word text there 2 times. So the first column is data, second column is document, third column is example, fourth column is extracting, and so on. This column is a text, and this column is used, and this column is useful. So that means each word in the dictionary is a column. Then it identifies the count. A particular word is there in sentence 1 or document 1, or a particular word is there in sentence 2 or document 2. If it is there, how many times? So in this case, the word text from the dictionary, okay, that is this particular column, it exists in sentence 3 2 times. So this is one way of doing representation. So you pass only this data along with this word, the column name, okay, something like this. Let me show you a little bit more, something like this, okay. So that each column is a word, that the column name, then the entry is over here, right? So similarly, for any sentence or any number of sentences or any number of documents, it can be one or more sentences, right? Be represented in like a matrix format, like mathematical format. That is called the bag of words representation. Okay, that's what we pass to the AI, so that AI understands this, then it does the remaining activities like a classification or clustering. All is done by machine learning using this mathematical matrix input. Okay, so there is another way of doing the representation. So I mean, as I said, what is representation? We convert the text data into another format. We represent that into AI or machine learning so that it can understand and use it for any kind of text mining, like a classification or retrieval or clustering, for any kind of topic modeling or sentiment analysis. It uses this representation or the mathematical input as an input for the remaining process. So that is one representation, is bag of words. The next one is called a term document matrix or document term matrix, either way. So here what we do, a corpus, that means many documents or many sentences, okay, is represented by a term document matrix. X, the document matrix is X, with M rows and N columns, okay. So where M is the number of terms, that means the words, right, the dictionary. The N is the number of documents or number of sentences. If it's only one sentence in a document, right? So that is the element of X contains the number of times ith term appears in the JS document. So what does it mean? So what we are saying here is, we are saying the term beautiful, that is the third term, okay, exists in the first column or the first document one time, right? So that's what we are saying here. So the element of X, the entire array, the X array, contains the number of times the ith term, in this case the third term, you know, appears in the GH document. In our case, the first document, right? How many times? So that's what this representation is. So this is called a term document matrix, or they call TDIF matrix. We can discuss more in the coming slides. So, but in the other case, in a structured data set like Oracle, relational database, or any other stuff, the number of records can be very large, but the number of attributes typically limited. What is the attribute? The number of columns. The number of columns usually we have probably in hundreds, not in millions, not in thousands, right? Maybe a table can have millions of rows, thousands of rows, but the number of columns of the attributes is going to be less than 100 or in hundreds. But here in a text representation, the number of columns equals to the dictionary size, the number of words in the dictionary, right? So in our case, let me go to that. So in this case, if I say this many words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in this particular case, 11 attributes are 11 columns, right? Because here we have very simple sentences. But in reality, we may have so many words, thousands and millions of words. So the number of columns are going to be huge, right? So many columns. So that's why we cannot use the structured data set. We cannot use like relational database. So that's why we use the text representation, either bag of words or TF-IDF, term document metric, and so on. There are so many other representations available. For example, there is a thing called the word bidirectional transformers. There they use the representation called encoding or text embedding or word embedding. There is a different representation. I will talk about that probably end of the session, but not now. So that's why we have to use this kind of text representation, not like a texted data set like Oracle relational database.
Excuse me, can you pause for a while? There's a kind of technical problems, a network issue.
Say one more time.
Can you hear me, sir?
You mean share again?
Yeah, one.
Oh, okay. Let me stop
2
sharing
minutes.
and share again.
Yeah.
Sure.
Yes.
Okay. Can you see now?
So
Can
we
you
are
see
able
now?
to see your screen. Our side we have a problem. Problem is
Oh,
not
I
on
see.
your side, sir. Yours is
Okay.
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 Yeah. Okay, sir. Since I have connected from my mobile, I'm able to see, I'm able to hear you, and I'm able to communicate with you. For the larger audience, the network issue is there in the system.
Okay.
So
Okay.
yeah, yes, you can continue, sir.
Is it fine now or still it's a problem?
Fine, sir.
Sir, it's clear, sir. You can continue, sir.
Okay. All right. Maybe next time we can go more details. For now, it's fine. Okay. So then how do we do a text processing? Okay. So now, so far what we did, we got the text, then we converted that into different representations, like a bag of words or TF-IDF, the text document representation, right? So now, how do you process the documentation? How do you process that represented input? So there is one a concept called or method called a case normalization. So what we do in that case, every term, that means every word or every phrase, we normalize that into lowercase. Okay, whether it's uppercase, lowercase, or camel case, or mixed up, whatever it is, we automatically the process will convert everything into lowercase. So all your entire dictionary, all the terms in the dictionary will be in lowercase. And also what it does, the next step, it will filter some of the common words that do not add meaningful content. For example, like the word the, of, and, but, from, or, we, right? So some of those words, those are common words that do not add any meaningful content to the document. For example, we came to the hotel service is good. What exactly we need? The service is good. Service good. That's all we need, right? We came, all those words are meaningless, right? That do not add any meaningful to identify the particular the classification or particular sentiment or topic, right? So that is called stop word removal. What is stop word removal? We filter or we remove all the words, all the common words that do not add any meaningful content, right? So that way, we will reduce the number of terms or number of words in the dictionary, then the number of columns will be reduced. Then the third concept is called stemming. I don't know whether you can see my screen. It's called stemming, like a stem, right? நம்ம இதை சொல்லுவோம்ல, இந்த மரத்துல தண்டு சொல்லுவோம்ல, stem, right? Stemming, right? So stemming is a process of reducing the words to their root form. So a non-changing portion. For example, let me give an example for stem. I have an example here. Let me see. Yeah. So when you say walking or walked or walk or walk, right? We convert everything into walk because walk is a root word. That is the root, right? Whether you say walk, walked, walking, whatever, it converts that into the root word called walk, right? That is called stemming. Okay. So any dictionary, if you have, for example, you have all 3 or 4 terms, walk, walking, walked, walks. If you remove all 4, keep only one term called walk, right? So that way we can reduce the number of terms in a dictionary or number of columns in our representation. The next one is called lemmatization, like a lemma, right? That is the process of converting the word to the root word. That is called a lemma, L-E-M-M-A, okay? Which is a valid word in the language. For example, when we say browsing, right? The browsing will be converted into browse in stemming because stemming only focuses on the stem, right? But in lemmatization, the browsing will be converted into browse, B-R-O-W-S-E. But in stemming, it will be converted into B-R-O-W-S, right? So that is the difference. Okay. And similarly, for the studies will be converted into S-T-U-D-I for stemming, but S-T-U-D-Y for lemmatization. Again, you may ask a question, which one I have to use for my machine learning model? Whether I would use stemming or lemmatization, or I would use stop words, I would use the normalization, case normalization. Probably you would use all, or you may use 2 or 3. It's up to you. Now, up to you how you define your model, machine learning model, how much you want to improve or fine tune the accuracy. So you can decide what you need. But these are different basic methods available for text mining so that you can use for your machine learning model. Then once you have the representation, then the text processing, you filter the data into small things, you remove some stuff, all those things. The next thing, we have to calculate the weight, the term frequency weight. So what is term frequency? The term, that is word, frequency. So how many times that word is there in the sentence, right? That is the frequency, right? So the term means word, frequency means number of occurrences, right? So the term frequency is the number of occurrences of a term, of a word in a document D, right? For a particular document, how many times that word, a sign exists, right? That is maybe like 2 times. Or in our example, I said the text exists in the 3rd sentence or 3rd document 2 times. So that means the term frequency for the word text in document 3 is 2, right? That is a TF, the term frequency. Then another terminology, another calculation is called inverse document frequency. Inverse document frequency. So it's defined as the total number of documents. So in our example, I showed you 3 documents or 3 sentences in this case. The total number of documents divided by the document frequency of term T. So that means if we have 3 documents in our case, right? Then a particular term in a document, say the same example, text. The document 3, the term, the text came only 2 times. So 3 by 2, 1.5 is the inverse document frequency, right? That is the total number of documents, the corpus that is in the upper, the top, the denominator, the TF of T, that is the term frequency of T, is the document frequency term for a particular term. Okay. That is called inverse document frequency. Then the third one is called a term frequency inverse document frequency. Basically, the term frequency multiplied by inverse document frequency. So that is the final outcome, the final calculation. So that means the term frequency inverse document frequency, that is TF-IDF. Term frequency inverse document frequency, that is TF-IDF, that measures the relative importance of the term. So that means the relative importance of a term or a word in a particular document, right? How important the word text in the document 3. Oh, it's very important because that came twice, right? The showing that importance in numbers. For example, the term text, the TF-IDF is 0.67. But another word called data, another word, but the TF-IDF measure is 0.25. So that means the 0.67 for text is having more importance than the word data because that had got only 0.27 in that particular document, right? The importance is measured using numbers or decimal values, right? So the importance increases proportionally to the number of times the term T or the word T appears in the document, but is offset by the frequency of terms in corpus of document or all the documents, right? So the TF-IDF can be used for stopword filtering. So what does it mean? Why are we talking about this? Maybe that word, a text, appear only one document, maybe 2 times or 3 times, but not in any other document. So in the overall, maybe it's important, maybe less, right? There's a possibility. But in a particular document, the document 3, in our example, the importance is high for the word or the term text, right? So that's how we measure, we know what is the importance, how important it is, and then how can we calculate the importance. So based on the importance, how can we find out the topic, the important topic from the document or from the corpus? That means from all documents, right? So I'm just showing an example now. I don't know whether you guys can see in your screen. I'm showing there are 8 documents in my example, okay? The sky is blue and beautiful. There is sentence in document 1. I love this blue and beautiful sky. That is in document 2 and so on. The last one is the dog is lazy, but the brown fox is quick. So like that, I have many different sentences in my screen, in my slide. So all this document, all these words in the document will be converted into a matrix, right? The term frequency. What is term frequency? The number of occurrences of a particular word or a term in a document, right? So in this example here, as I even explained before, the word beautiful exists in document 1 and document 4 and and document 7 and so on, right? So we are finding the term frequency of each word, that is the column in the dictionary, and then we are forming this matrix. The term frequency inverse document frequency, that is the TF-IDF matrix. So here we calculate this TF-IDF. That means the TF multiplied by IDF, right? We are calculating this, then getting these numbers. For example, beautiful in document 1 is 0.49, in document 7, 0.60. So that is very important. That means the word beautiful is very important in document 7 and so on, okay? Why I'm saying this document 7? Because we're starting from 0, just like an array. An array starts from 0, right? But basically 0 is document 1, document 2, document 3, so on. That's why I'm saying this is document 7 with the beautiful has, the word beautiful, the term beautiful has the TF-IDF value 0.60. That means that term is very important in document 7. Okay. So this is how we calculate, this is how we feed the input to the AI model to do different text mining. Then this is the last probably in this introduction session, similarity or cosine similarity. So what is similarity? we measure, if you have two sentences, or one word and one sentence, right? You have or two words, or anything like A and B. How similar these two? Okay. For example, let me show an example in my. I hope you can see it. So in this three sentences here, what I'm showing, the cat is on the mat, sentence 1. There is a cat sitting on the mat, sentence 2. A dog is playing outside, there is sentence 3. So in this example, these two sentences are similar because both are talking about cat, right? The third sentence is not similar to sentence 2 or sentence 1 because it talks about dog, right? But we can read and we can find from our brain, but how the computer can understand this, how the computer can identify how these sentences are similar, right? That's where we talk about this cosine similarity, okay? So how do you calculate cosine similarity? The cosine similarity is a measure that's commonly used in information retrieval to find relevant documents that match the query keywords. The query keyword. Keywords in this case, the term or multiple terms or multiple words, right? So similarity, the function is the cos theta. That means similarity A comma B. The cos theta, that is A dot B divided by A and B, right? So basically this is the AI multiplied by BI divided by the each term A, for each document M, there is AI square root of that multiplied by square root of BI square, right? That is the denominator. So once you have this, you will find the theta. The theta will tell you how close those two sentences are or how far those two sentences are. Okay. So the angle will tell you how close or how far those two words or sentences. So from the calculation, so basically what we are doing, we are just doing mathematical calculation. That's all we do even in every machine learning model, right? So we calculate those mathematical measurements internally in the machine learning model. Then we identify how close those two sentences or documents or words or phrases, right? Any questions so far before I dive into the practical session? Okay. If you guys don't have any questions, let me go back to the practical session. Let me look at the chat. All right, good. So now let's talk about, let me show you some examples. Okay. Let me go to the top. I hope you all can see my Jupyter notebook, hopefully in your screen. Or you can watch the recording later. I hope you are recording the session too in your YouTube. If that is the case, you can watch it later. So here what I'm doing is, this one example I showed you before. I'm putting 3 documents in an array, document 1, document 2, document 3, in an array of documents. Then I have a library called scikit-learn. Probably you guys know the NLTK libraries and scikit-learn library. So NLTK library you can use for filtering the stop words, right? The one I mentioned before can remove the words those are not giving any meaningful to the extraction, like the and from to. Now it will remove all those stop words. Then this counter vectorizer from the scikit-learn will give you the bag of words, the matrix, right? So what I do here, I call the count vectorizer. Then I'm saying convert everything into lowercase, all my sentences into lowercase. Okay. then a stop word English. That means it will automatically, the reason why we are calling NLTK, it knows all the stop words in English, then it removes those words automatically. Okay. So then here we are doing the transformation. What is transformation? We are doing the text representation, the matrix form, right? We are converting into like this, right? We're converting to matrix. And then once you have the transformation, from the transformation, you can get the vocabulary or the dictionary or the column names or all the terms, right? That is called the vocabulary. We can print that, as well as we can print the entire bag of word representation. This is one example. The other example is I'm reading from many different files. I have, let me show you. Let me show you the. So in this case, if you look at my file explorer, I have a folder called Animal Food Weather. Underneath, I have 3 other folders. And each folder has different documents, right? And food has different documents. Maybe this document 4 and 5 only talks about food. And the weather folder has 3 documents. Probably those talk about only about weather. Then the animals folder or the directory has 3 documents. Probably talks about animals, right? So, but what I'm doing here, I'm just reading from the folder all the documents, just one read, right? Just one read. That's what I'm doing here. So there is in scikit-learn, there's a library called load file. Okay. So when you call that load file, it reads all the files under this folder, even subfolders. It goes till the bottom, till the root. It takes all the subfolders, the entire bottom. Whenever it sees different text files, it reads all the files. Then it forms a single array of sentences, right? Because in my case, in one folder, I got 3 documents, another folder got 2 documents, another folder got 3 documents. It read everything. It formed a single array, right? So this is maybe document 1, right? The second one probably document 2 and so on. So I read all documents now. Then what I do, yeah, I'm just showing all the documents here. Then what I'm doing here, the document got 2 columns, text and category, right? So I'm converting those into some numbers. So if it is food, say it's 1. If it is weather, say 2, and so on. Like I'm converting those into numbers. Maybe some of you know already when you do any regression models, like logical regression models or SVM, support vector machines, you convert the labels or the text columns, like yes, no, something like that. You convert that into numbers, right? So you do that way. Give me 1 second. Give me 1 second there. Sorry, I got some important calls here. So we're converting that into numbers, or we call one-hot encoding, or we call get dummies, right? We are converting any classified labels into numbers, right? Similarly here, each document has a different category, like a weather, animal, talks about animals or food. So those categories, we're converting those into numbers. Then what we do, we call the count vectorizer, the one we did before. And then we do a fit transformation. So we are basically converting the entire text into the TF IDF representation, like the entire matrix, right? As I explained before, this is only the term frequency. How many times each term or each word exists in a particular document, document 1, document 2, up to document 8, right? Then what we do after, I'm just showing the dictionary. So all these words are in the dictionary, right? We have that. Then what we do here, we are calling the TF-IDF transformer from scikit-learn. We call this transformer. Then this transformer, we are parsing our dictionary. So we are basically sending this, the count vectors, then we are passing that into the transformer. That will automatically calculate the TF-IDF, the term frequency, inverse document frequency calculation. It does automatically and generates a new matrix. So you don't need to calculate manually, right? You don't need to calculate anything like that, right? You just pass the metric where you have the term frequency, then automatically convert that into a TF-IDF calculation. Once you have this, then you can use it for different classification model, any other model. Okay, so you can do that part. So why do we do this? Let me give an example. So similar to this, different, each word we create the term frequency and all those things, right? Similar to this, there is a machine learning model called BERT, bidirectional transformer model, right? So what this model, this is from Hugging Face. If you go to Hugging Face, Hugging Face, SBERT model, you can see so many examples like this, sentence transformers, Hugging Face transformers. You can see so many documents, right? You can learn more later. Okay, I'm not going through the actual model. I'm talking about how this model is working, how it is useful, how this model is doing the text representation, the conversion, right? So what they do in a BERT model, they already converted or represented or embedded, all are same, right? Are embedded or encoded, millions of words, millions of words in a document. They already converted into a matrix. For example, there's a word called queen. For that word queen, they have 768 attributes. Maybe like one attribute, maybe queen is a female. Yes or no? Yes means one. Or queen means a particular title or a particular position. Yes or no? Like that, there are 768 categories of that one word queen, right? They have different numbers, like a 0.68 or 0.1. Like that, they measured, they already have a pre-trained model. So why do we need that? When you want to find out the similarity between two words, king and queen, okay? Because the king and queen comes under a position or a title or some kind of a high level position, right? Or ruling, right? So both comes under that category. Both are same. How do we know? The BERT model, the pre-trained model, already have similar measurements or similar representation, but for each word, 768 measurements for each word, individual word. For example, the queen and the men are same? Probably not, because queen is female, men is male, right? Are men and king are same? Probably yes, because the king can be a male in this case, right? So that means the men or man and king can be same. How does it know? The pre-trained 768 attributes, the values probably same for man and king. That's how the cosine similarity will know the angle is very small, that means the word man and king are very close. Okay. So, but why do we need this? Why do we call pre-trained model? You don't need to develop your own model. You just call this sentence transformer, then call this name. Like this, there are so many models, so many pre-trained models already available in Hugging Face, for example. Okay? When you call this sentence transformer via online, right, this code, it automatically downloads this model, the pre-trained model. It uses this model to find the similarity. Okay? So what we are doing here, we are loading already available model. Let me make sure time is okay. Yeah. So we are loading the available model online. Then we are passing 3 sentences. Then we are doing encoding. What is encoding? These sentences will be converted into metrics like this, right? But using the pre-trained the representation for every word. Maybe for a cat, already the BERT model knows the 768 attributes. Cat can be an animal, it can be a small puppy, it's not a human being, like that. They have many different categories already. That 768 attributes will tell what is cat, the numbers, right? The values. So like that, we are doing encoding part for all 3 sentences. Then what we do, the embedding 0, that is for sentence 1, the embedding 1 for sentence 2, right? So we are doing embedding, we are passing the embedding value into cosine similarity, right? So because when you put dot, for both, right, 1 and 2, right? We are doing that. Or we can do something like this. 0, 0 and 1, 0, 1. That means in the sentence 1 and 2, then sentence 2 and 3, right? So if we look at the similarity, for sentence 1 and 2, the value is 0.92. Give me one more second, please. Sorry. So, sorry. So here, the similarity is between 0 and 1. So 0 means no similarity. 1 means very close or almost equal or equal, right? 1 means equal. 0 means no, not even equal, not even same. So, but here we got 0.92 for sentence 1 and 2. That means sentence 1 and 2 are very close, or both are talking about a same context, a similar context, right? But if you look at this one, the sentence 1 and 3, the similarity is 0.022. It's not even 0.1. So that means far away, right? So that means the sentence 1 and 3 are not same. Talks about two different things. All right. So this is how in BERT model or sentence transformer SBERT model, they find the similarity between two sentences. For example, let me give another example. So here I have the reviews and responses. For any particular product or any particular hotel reviews, when you go to the hotel, you stay there, you give a review. If the review is bad or good, the manager of the hotel will respond back. For example, when after you come back from the hotel and the online, you say, we were staying in your hotel on the particular day. The bathroom service is very poor. The water pipe is leaking, or the room is not very clean. Then what will happen for that review? The manager of the hotel will respond back. Okay, he may say, I really apologize for your inconvenience. We went to that room. We fixed that problem. Please come next time. You won't see that problem. That may be one response. The other response may be, oh, sorry about that. Come next time, with no other details. Or he may say, sorry, that's it, only one word. Similarly, when you give positive response, oh, we came to your hotel, the food was awesome, very tasty, our entire family loved it, we will come to your hotel next time too. Then he may respond back, thank you. Two words. Or he may say, oh, thank you for giving a great feedback. Please come next time and inform us in advance. We will take care of you the same way next time also. We will make sure our food quality is really good. So the detailed response. So the response can be anything. But how do you know the review is matching the response, or the response from the manager is similar or same as, or the context is same for the review? How do you find that? Okay, are you going to read each and every review and response? If you are going to get millions of reviews and response, you cannot, right? That is one of the example of text mining, where automatically our machine learning model will identify whether these two sentences are same or similar, or how similar, or the review is a positive review or negative review, or the response from the manager is positive or negative, or is it close enough, or it has any clarity, or when the reviewer, the customer, when they read the response later after a month or two, can he or she give any credibility? So all those things you can measure in advance using our machine learning model. So one of the model is called ChatGPT. You guys all know, right? The ChatGPT model. So ChatGPT, you can have your own account, but you have to pay for it, because for do all those things, you have to pay for it. I paid my monthly payment. Okay. So once you have the account, you can have a token, an access token. Then you can pass your sentence or sentences. The beauty of ChatGPT is, let me show you that. This is the important thing. Okay. You can even tell what you want in sentences. Okay. So here what I'm saying, read this line carefully here. I'm saying, as an AI with expertise in language and emotional analysis, your task, I'm telling the AI, ChatGPT, your task should be, based on the review and response provided here as the input, analyze the response statement, provide the sentiment, whether it's positive or negative, or rate the narrative, whether the narration is good or bad, rate between 0 to 10. 0 is low, 10 is high. And also tell how well the storytelling from the manager, okay, for the review. And also find out any solution provided by the manager for any complaint for the review, from the review. And also measure any refund provided or any credits or discounts provided for any complaint. And how good is the solution, whether the solution is acceptable, how credibility it is. I'm asking all the things in one sentence. Okay. So based on my sentence, what I'm asking for my input, after that I'm passing many inputs here, right? I'm showing many inputs. For those inputs, for example, for this particular review and this particular response, what I'm showing here, then the review is, the customer is saying that we came to your boutique and we felt it is overpriced, deceptively market budget hotel. The only good thing is the location is good. Other than that, very small room, it's overpriced, or the furnitures are very dirty, the carpets are very dirty. Basically, they're complaining. Okay. Then the manager is responding back. Okay. Thank you for your feedback, and our rooms are very smaller, that we know. Even we mentioned that in our website already, I don't know why you haven't read that, blah, 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 but please come next time. Like that, he's responding back. So now the chat GPT, based on this input, the review and response of the input, it's identifying the sentiment. Here it says saying the sentiment is neutral. The narrative, it's rating as 4 out of 10. The solution rating, it says 3 out of 10. The credibility of the response, how credible the response when someone reads the response, it says 7 out of 10. Then the clarification, whether it's all the complaints in the review are clarified by the manager in the response, it says 6 out of 10 rating. The refund is provided. In this case, it says 0 or no. Okay? The next beauty part is, it even explains why it rated the solution 3 out of 10, or the credibility 7 out of 10, or the sentiment is neutral. It says the sentiment of the response is neutral as it acknowledges the feedback without strong positive or negative language. The narrative is somewhat low. That's why the scoring is 4 out of 10. And the solution rating is very low, 3, because the response offers to discuss how to set the expectations better, but does not provide any concrete solution. So it identifies in the difference between those two sentences, how similar, what is the credibility, are any solution provided, any clarification is properly added, what is the rating, and also it explains why ChatGPT provided that rating. Everything is one, maybe like few lines of code. If you look at here, ignore the others, only this, I'm just reading the data file, probably not only this, only this function I'm calling, no other function I'm calling, only this function I'm calling. Then I'm just putting some review response in sentences. I'm calling that function. That's it. Probably 10 lines. I'm getting all this analysis within 10 lines in a few seconds. Here, I'm doing it for a few sentences. But what I'm doing in the top, I'm reading from a CSV file, both the reviews and responses, right? Then I'm storing the output in another CSV file. What is the output? The rating, right? The rating is what I got here. And how many reviews and responses I got here? Probably 80,000 or 800,000. And storing the analysis output immediately here. It may take a couple of hours or maybe even a day. But still, we are not reading each and every review and response manually and manually rating it. It's done automatically with proper explanation. That is the topmost power of text mining. Okay, let me stop here. So if you guys have any questions, you can ask now.
Excuse me, sir. Sir.
Your voice is echoing, or you can type the question in the chat. I'm okay with that too. You can type it in the chat, or you can ask if there is no echo.
When you sit on mute, it's Sir, you are giving examples. Am I audible, sir? 3 sentences that their cat is on the mat, sitting on the mat, and dog. So, as a human being, when we read, I can just find out the relation that it is talking about animals. But when it sees only the word cat and dog, it may say that there is no similarity. But when we people read, we can find out the similarity I just think that we can find out it is talking about in general animals. So is there any other thing we can do with this? Are you getting my question, sir? Am I making myself clear? No, the only that statements I'm looking into, sir. The cat, the second statement also has a cat. The third statement says it is a dog. So when I read, I just find out some similarity. I just think that it is talking in general about animals. All the three segments are related. But our algorithm, if you use, uh, uh, so is it we have to tune it to find it out? It is talking about animals, or because we said that it will say that's no similarity, then it is encoding in.
Good question. Yeah. So it depends on what you want to do in your machine learning model. For example, you want to find the classification. You want to classify the document. Okay. Maybe you want to classify, oh, all these three documents are talking about animals, right? Or the last two sentences are talking about animals, right? So for classification, if you do that way, of course, dog and cat, both animals, so both will come under the same category, right? Obviously, right? But here, in this particular case, what they are doing, the sentences, there is a cat, and the cat is doing something. That means the cat is on the mat. The next one is cat sitting on the mat. So very close, right? So not only they're talking about animals, the animal is sitting somewhere. So that place is mat. So it's looking each and every word and then finding the close enough. And the third sentence, a dog is playing outside. So dog, even though it's animal, it's a different animal. And also it's not sitting anywhere, it's playing. And also not in the mat, it's sitting outside. So you see the difference, right? So that's why the BERT model, the SBERT sentence transformer model, knows the meaning of each and every word. Then it identifies how close enough. If the dog is not an animal, then you won't even get 0.022. You may even get 0, right? Because dog is close to cat, that's why you are getting 0.022 in this case. Okay. But here it considers not only that word, it considers all other meaningful terms or the dictionary words, right? That's why the difference in the measure. But if your requirement is not finding the similarity, your requirement is finding the classification, right? In that case, for example, this example here, the top. So once you have this kind of a metric with a TF-IDF, you can find the classification. So you can say, for example, here we got 3 categories, right? One is weather, animal, and food, right? So if you go down, if you look at the words, the animals like a fox will be in some range, the 0.45, 0.42 range. But if you look at the sky, maybe different range. So based on the TF-IDF, you can classify whether that word is comes under weather, or comes under animals, or comes under food. Or you can say this particular document comes under weather or animal or food. Okay, you can do that also.
Thank you so much, sir. It's clear. Thank you.
No problem. Any other question? Even if you have any other question later, maybe you may not think now, any other question or any project you guys would like to do in this area, send me an email. I will send a mail to Professor Sister Rita, so you guys can send me an email. I can guide you guys later also. Okay?
Sir, excuse me. See, you have presented the text mining in a simple and effective way.
But I wanted to know one thing that up to this matrix formation from the text given,
Mhm.
is it possible for the UG students to create up to that matrix format with any programming or any facility available for that with that algorithm?
I can send you this code. You guys can use this code.
Which one, sir?
I can send you this code. Or even if you go to even if you Google it, right? If you go to TF IDF in Python, right? If you can get many examples. You know, for example, if you I don't know whether you guys know the Medium. You know Medium, and there is a Medium website. So you need to have. I can even sign in continuously. I need to have an account for this, but it's free in my case. So there are so many articles available with examples. Not only articles, right? They even talk about the examples with the Python code. You can just use it. They even explain how the calculation happened. Everything they explain here. Let me put it in the chat also. Okay, I mean you can use it later too. So like that, there are. Oh, I cannot copy. It's not allowing me to copy. Let me see. Okay, it's not allowing me to copy, but but you can go to Medium. Okay, you can do this. Yeah, I'm just putting in the chat. So like that, you can go to medium.com. There are so many articles, not only for TF IDF, even for Bagabird, for Bird, SBird, or any deep learning models, or even GPT-4 models. There are so many articles available with data, with code. That is important, right? With explanation too. Okay. So if you guys want, you can go there. You can go through more articles. You can even explain to the students. Our students can even do the presentation after they read outside the class. They can do the presentation in the class for other students too, especially the master's students or the final year bachelor students. They can do.
Thank you, sir. Sir, another question. When you said that application of this text mining for the reviews and responses, is there any possibility to have a problem with that response generator? It is automatic
Problem.
from the reviews given, isn't it? Am I clear, sir?
What do you mean by a problem with the response generator? What do you mean by that?
It should be a positive response, isn't it?
Oh yeah, you can generate that. It can even classify whether the response is positive or negative. Yeah, everything will be done from the code, not manually.
Not manually. That's why I'm asking, is there any possibility to have unwanted response which we are not expecting?
It's possible. It's possible because some models, okay, some models. For example, if you do your TF IDF with support vector machine or with the largest regression where you want to find the sentiment analysis like a positive or negative, there is a possibility. I have an example code also. Let me see. Yeah, here. Okay. So I have some SVM way of finding the sentiment. But if you look at the accuracy, only 0.82. Okay. Or precision only 0.75. So that means it's not going to find always accurately. It's going to do mistakes. But what I noticed in GPT-4 or in BERT models, the accuracy is really high, like 95% or 99%, something like that.
Thank you, sir. Thank you, sir.
Okay, so I think I have to go. They're calling me for I have to go for something. So thank you all. Thank you for your time. This almost 70, 80 minutes for the patiently, listening to my talk and understanding more. And even if you have more doubts or any clarifications needed, feel free to send me an email. I will explain. Probably in the next semester, if we get a chance, I can talk about different latest trends in AI. I hope we can make it. and see you guys probably next semester. Okay. Thank you all. Have a really great day. God bless you.
We're having a vote of thanks for you.
Please go ahead. Please go ahead.
Thank you, sir, for your clear and wonderful explanation. We hope that we would make the best out of this webinar. Due to your clear explanation and crystal words of webinar, no doubts arise. Thank you, sir. I now call upon Ms. Catherine Winston of 3rd BSc Computer Science to propose the vote of thanks. Good afternoon, everyone. I am honored to extend my heartfelt gratitude to our esteemed resource person, Xavier Babu, Senior Director at Public 6 Epsilon and Adjunct Faculty at Northeastern and UMAAS Lowell, US, for delivering outstanding presentation and contributed to the success of this international webinar. So, you taught us about hidden patterns, text representation, information feature extraction, text clustering, text clarification, information retrieval, and different terminologies of text mining. And your practical session was more useful, sir. We gained a lot of knowledge about text mining. Thank you, sir, for your expertise and making this webinar insightful. Actually, we thought of asking your valuable time for us in future. But as yourself, you have given opportunity for juniors. Thank you, sir. And I would like to express profound appreciation to our Secretary, Reverend Dr. Sister Shishibana, our Principal, Reverend Dr. Sister Jessie Fernando, and our Deputy Principal, Dr. Sister Corrine Torres, for their invaluable support and encouragement. Special thanks to our beloved HOD, Reverend Sister Kirita, for her moral support, guidance, and coordinating the international webinar. I appreciate the effort of our department staff for their contribution to the webinar success. A sincere thanks to the digital team for providing essential technical support. Your efforts are truly appreciated. Last but not least, my gratitude extends to our enthusiastic students whose presence and cooperation enriched this international webinar. Once again, I express my gratitude to everyone for your cordial cooperation. Thank you. Thank you, sir.
Okay. Thank you all. Take care. Bye.
Yes.